מתרגשת להזמין לבמה את האסטרונאוט איתן סטיבה שיח אסטרונאוטים עם האסטרונאוטית ג'סיקה אייר על חזרת האנושות לירח ולמאדים ועל החשיבות של Human Space Flight במשימות האלה.
עובד.
Hi, Jessica. So before my mission, I was invited by Jessica to a bar, and then she gave me all the clues about things you can do in the space station, and thank you for that. But here we are in a full house of educators and space enthusiasts, and I'll say a few words, and then we'll ask you a lot of questions. Thank you for attending. Last year you were here, right? Well, that was 2 years ago.
Okay, yes, sounds good. It's wonderful to be here, at least virtually, and to have some small part in the role this year for Israeli Space Week. Hello to everybody.
Thanks. So I'll say a few words about the significance of astronauts. So I'll ask you about the significance of human beings, because the answer is very similar. Human beings are defined by curiosity. That is what brings us to explore, to learn, to do everything in life. And that is our nature, curiosity. And especially when it comes to the mysteries of our planet, of the universe, and beyond it. The significance of astronaut is constantly evolving from a role that was defined initially by competition during the Cold War through wide international cooperation, creating the ISS. Today, the third phase is space exploration by private entities. During my AX-1 mission, the first private commercial mission to the ISS about 2 years ago, NASA, ESA, Roscosmos, and private astronauts all worked together, understanding that they can use the scarce resources of oxygen, water, food, energy, and lab availability. And maybe most importantly, several times during the mission, we shared our perspectives and our amazement at what we are experiencing. The motto of the Rakia mission was Space for All. To meet that goal, we open-sourced the mission, inviting proposals from scientists, artists, students, educators, even those in this room participated. And they came with a bunch of ideas, exciting ideas, incredible ideas to do up there. One of the experiments was related to CRISPR-based genetic diagnostics. Another was about optical lenses and creating actually in space production, manufacturing. In collaboration with atmospheric researchers, we studied electrical discharge phenomena in the upper part of the atmosphere called TLEs, an experiment that the AX-3 team that we just saw are continuing. We engage artists, philosophers, poets in the mission, and that was really bringing so many people to join the effort. 1 minute. Really, we got so many people to join the effort, and they passed this experience to all their students, all their families, and everyone that could take part in that. So, the impact of us and Earth, this was the biggest thing that happened here for me, for the people that participated, and this was the first time a space mission measured its contributions according to the UN, United Nations Sustainable Development Goals, from quality education, good health, climate action, to industry and innovation. So, now I want to ask you a question, which I was asked and I really don't know the answer. Jessica, do you think AI and robots will replace you, live astronauts?
That is a good question. Of course, AI has received an increasing amount of attention lately for very good reason. But in my eyes, I don't think that robots or AI will ever completely replace astronauts. And some of the examples that I rely on for that one is if you look back to the Apollo mission, for example, we covered such an enormous amount of ground and time when we had the astronauts there on the surface compared to a very, very small subset of that could be accomplished by a robotic rover, for example. And if you look at some of the main differences, I think the ones really worth pointing out are that as humans versus a robot, and of course things could arguably be different with AI, but if you are first just comparing a robot and a human, then if you think about what that robot can achieve, everything that it can achieve or react to or demonstrate is something that was already pre-programmed into it. So, maybe if you had a communications link, you could change, but there would still be a delay in that. And you wouldn't have that kind of decision-making capability and that ability to adapt and react to something unexpected that the human brain can, of course, do so well. So I think, to me, that's one of the main advantages of having a human, is that you can quickly react to an unexpected situation. And, I think that there will always be a role for both. And that's the way I like to think about it, not as if it's like this competition and it needs to be one or the other, but there is a role for each. And I think we work well in concert with each other. For example, if we're going to launch a spacecraft to a new planet, we want to probably do that with a robotic rover first so that we can measure different aspects of the environment, like we've done with the various Martian rovers in the past. And then later, on later missions, when we want to be able to have that quick thinking, that ability to react and to the unexpected especially, we want to have that human brain and that element there as well. But it is a very interesting question you pose, I think, for the role of AI, because if you do have this AI that is able to adapt and react and deal with these unexpected situations, then perhaps you're getting closer to that kind of reality. But, to me, kind of how you started off this whole talk with that spirit of humankind and this curiosity that we all have, that to me is something that is only going to be truly represented in us, in the human species, and that is something so worthwhile in terms of making sure that we as a species continue to evolve and explore further.
Thanks for that. I spoke to a former NASA astronaut and MIT professor, Jeff Hoffman, and he wished he had an astronaut on Mars to activate and troubleshoot his rover there and activate his MOXIE oxygen experiment. And it would be his dream, because every message takes a week each direction. So
exactly.
maybe you can give us some insight about the current status of the Artemis program after the great success of Artemis 1.
Yes, certainly. So Artemis, for anybody that's not familiar, is of course our mission to return astronauts back to the surface of the moon. And there are various phases of that mission. And, even looking beyond that, the exciting prospect is that we will use everything that we learn on the moon to eventually propel us toward Mars, toward that next great destination. So as you mentioned, we had a very successful test flight of Artemis 1, and that was a test flight of both the Orion capsule that will hold the astronauts and the Space Launch System, the rocket that will launch those astronauts. Now we have relatively recently assigned the Artemis 2 crew. So we have 3 American astronauts and a Canadian astronaut that have been named that will ride in that Orion capsule the first time that it has humans in it. That will be the Artemis 2 mission, which is currently scheduled to launch in September of 2025. And that mission will go all the way around the moon. It'll go even further than the Apollo missions did. The maximum will be about 40,000 miles, I believe, away on the far side of the moon. And then they will return. So that will be a 10-day mission. They won't be landing on the moon. They'll just be achieving that, the first time in decades that we've achieved that orbit around the moon, and then they'll be coming back to Earth after 10 days. Then things get even more exciting after that when we start having Artemis 3 missions and beyond, and that will be a series of missions that will have us landing and setting foot on the moon. So of course, our goal is to be there walking around, doing more scientific experiments. We have the gateway element, which is kind of like a mini space station that will be in orbit around the moon that you can use for spacewalk excursions down to the surface of the moon, for microgravity research, as a platform and stepping stone to other destinations as well. So
Jessica, but what's taking so long? Apollo program, within a few years, you put people on the moon, you put rovers on the moon, and now you're really taking your time, step by step, to achieve the same things and more. What is the difference between Apollo and Artemis?
Yeah, I think there are a few main differences. First of all, of course, the technology is entirely different than it was in the 60s and 70s. So even though it has been done before, there's nothing easy about going to the moon, and we are recreating all of that with new technology. But I think some of the main differences are really best looked at from a historical perspective of what was happening at that time. And the reason why we were able to undertake the Apollo missions and get to the moon so quickly the first time was because we had a very strong political driver. We had the Cold War and the space race. And because of that, the American government wanted to invest very heavily in this goal. So at that time, the Apollo budget was 4% of the national budget, which is huge compared to what the entire NASA budget is now. 4% versus now the entire NASA budget, not just the Artemis program, but everything that we do at NASA with the International Space Station, with satellites, remote sensing, everything is less than 0.5% of the national budget. So we're talking about orders of magnitude, different amount of expenditure and resources, which is why things, I think, are moving a little bit more slowly now. But the way that we're doing it also is a lot different now. We have all of these collaborations with private industry, with international, really with international space agencies as well. And so that's another big difference where we're working together like we do on the International Space Station in order to the biggest driver, I would say, toward maybe the reason why things move slowly, first of all, that different level of resource expenditure, as I mentioned, but also safety. You know, every time, everything that we do here at NASA, as you know from your own space flight, safety is the utmost priority. And so we want to make sure that we are truly ready to fly astronauts on this space capsule and rocket, before we undertake that next mission. So as we do things incrementally here at NASA, we will get there at the right time. And it's a very exciting time for all of us with the Artemis missions now really close at hand.
Our crew went through training it was planned for 5 or 6 months. It went on for 7 months. What is the difference today with the training of astronauts towards the missions to the moon?
So for professional astronauts right now, for the space station, we spend about 1.5 to 2 years of training. Since we're up there for long duration missions, typically around 6 months, we're doing everything from spacewalks to flying the robotic arm to fixing the toilet, changing the light bulb, and doing the scientific experiments. So a lot of different types of training. The training flow for the Artemis mission is going to be kind of similar to that. It will be variable. It's actually not even yet defined for all of those missions. But for the Artemis 3 mission, I think we're looking at about an 18-month to 24-month, so 1.5 to 2 years of training before that mission. And then you'll see some differences probably in the later Artemis missions, ones that are particularly heavy in spacewalk geology type, planetary geology type sciences. So those flows are still being developed now, but I think we'll probably typically see about a 1.5 or so of training for those missions.
Can you tell us about your last week training, special training you had?
Yes, absolutely. So, right now, the only Artemis crew that's in training for a particular mission is the Artemis 2 crew that we mentioned, getting ready for their launch in September of 2025. But once we name the crews for the other missions, they'll be in their mission-specific training. But before that, most of us astronauts are involved in some type of development or training to kind of prepare the astronaut corps at large for the conditions that we'll experience and for things that might help us progress toward these landings. So last week, I was actually in Colorado flying helicopters, learning to fly helicopters. I had some basic helicopter training a couple years ago in Alabama with the Army, and then this was the next phase of that. This was a high altitude course. So there are a lot of things about helicopter flight that are, more similar than, say, flying an airplane to how we will land on the moon. The vertical profile, takeoff and descent profile is, of course, more similar to what we'll experience on the moon. When you're flying at high altitude, you have power and thrust limitations because, of course, as the altitude increases, the density of air decreases. And of course, on the moon, there's no air at all. So you have to deal with this very limited thrust and power as well. and also what we call degraded visual environments. So if you're flying a helicopter in the Colorado Rockies, like I was last week, and you go to land, you blow up all this snow that now suddenly obscures your landing, and you can't even see where you're landing, so you have to use different techniques in order to compensate for that. And that's very similar to what we'll experience when we land a lunar lander on the surface of the moon as well. So all of these types of high-intensity, dynamic operational environments are helping us prepare astronauts to get ready before they'll start training for these upcoming Artemis missions.
I would like to ask you a practical question. On the International Space Station, you collect the garbage and you split it to different parts, and then you put it in different bags, and then you stuff it all into a cargo vehicle, and then it's released and burnt in the atmosphere. So not every falling star is good for a wish, right? But what do you do with the garbage on the gateway? I mean, there's no atmosphere to do it. I don't see NASA bringing garbage back home from the moon.
Yeah, so the gateway, as we talked a little bit about, will be this kind of small space station in orbit around the moon. And I don't actually have the specifics of the plan, but I think what's going to happen is that the garbage will be accounted for either coming home or being deposited into HLS. So the HLS, the human landing system, the lander that's being built by SpaceX for the first 2 missions, and then Blue Origin after that, that lander, may or may not be reused. And there's a complex architecture for the lunar lander in terms of other vehicles that will be in orbit in order to refuel the lander itself. So some of those, at least in the beginning, some of those will not be reused. It will be expendable, so perhaps some of the trash will go in that vehicle, and then some of it may come back. But we'll have to see. I'll have to get back to you with some of those updated plans as we progress towards Gateway.
Thank you for that. So. Yeah, some inventions are starting to pop up here in the audience, so we'll send them over. About deep space missions and international cooperation, do you believe that is necessary, or the U.S. will go on its own? Israel signed the Artemis Accord. Will Israel have an astronaut on one of the missions? And how do you see the private sector participating in all those very expensive and risky missions?
Yeah, I think that there is a role for everyone, and I think that collaboration is the key to doing things better and making them more interesting and more successful. And part of that goes back to some of the previous question when we talked about the resources. As I mentioned, NASA doesn't have the budget that it did back in the 60s and 70s. No single country really has those types of budgets anymore. And so I think we need to work together to accomplish these great goals. But, more if you look at all of these different business models, for example, or experiments that have been done here on the ground, when you have teams that are more diverse, they have representatives from different backgrounds, different genders, different types of people, those teams are more effective and they're more successful and they're more content. So when we do things together, I think that we generate a different level of creativity and problem solving that will really help us solve those problems that we'll need to solve for these next great steps, the next great moonshot, if you will. So I think that there is a role for everyone. And I know, as I mentioned, Artemis truly is an international program, and that's a very exciting point about the entire space station, the Artemis program, living and working together. I'm not sure yet what's in store for an Israeli astronaut. That's probably, you'll know more about that than I would right now, but I'm very happy to represent Israel, of course, in any capacity that I can, as you know, with all of my family over there as well. So I'll keep doing my part as I can.
We'll take that as a promise and teach you some Hebrew words on the way. Maybe you can discuss a bit the outreach, the education that NASA, the tools that NASA offers the educators in order to give them the ability to inspire the students.
Yeah, actually, we have a few slides that we'll bring up here because I know for this audience, we were hoping that we could have some impact and share some of the resources that we have here. NASA does have outreach and education as really one of our primary objectives, and there are a lot of resources for educators. If you go to the nasa.gov website, you can see, for example, for educators, all of these different resource collections that we have to teach STEM topics. So you can search all of those resources by topic, by discipline, that kind of thing. And if you saw that code there, you can scan it in order to get right back there. I'm gonna flash that code back up one more time. So if you didn't get it now, you can scan this QRL code now and come to these different collections. Go to the next one.
That's very useful.
So
very helpful.
we have, so as mentioned, you can search by theme, by grade level, by subject. Keep going. And then we have we have a newsletter, a monthly newsletter that has Earth and climate science resources. So the audience here for educators and different grade levels. So another code you can scan if you're interested in this. And we also have various STEM engagement resources. So we have different resources here that will connect teachers and students and parents and caregivers to the work that we're doing here at NASA. For example, for students, there's even this first digital interactive graphic novel that I kind of helped launch as well. Really interesting stuff here, exciting stuff, I think, for some students to kind of look at it from this kind of graphic novel perspective and kind of come along on the NASA mission. And a few more NASA resources here for kids and students. You can really find your place in space, hopefully at all these different levels, as you see here, from young students all the way through college students. We also have different challenges for students that can be joined, and a lot of these challenges are actually open to an international audience, so they are worldwide. For example, different Artemis challenges that exist here with technologies, the Human Exploration Rover Challenge as well. This is one of the worldwide challenges that you could participate in. And then lastly, I think we'll wrap up with talking about some international internships. And again, international here, you can be a NASA intern coming from various other countries, Israel included. So just a few examples. I hope that's a little bit helpful, but this is really one of our main objectives here at NASA is outreach and education, not just here in the US, but really worldwide. So I hope that all of you are able to get something out of this and join us on NASA's mission.
Thank you so much for that.
And we can send those slides, if anybody wasn't able to scan, we'll make sure that we send those slides to all of you so you can distribute them around to the different educators and schools.
Thank you so much. And when are you going to space again?
I don't have a launch date quite yet. We'll see. As we were talking about, we have the Artemis program. Some of those launch dates have been a little bit delayed. As you said, things take time, but we still have active missions to the International Space Station. So there's a chance I could be on a mission back to the space station again, maybe a space station mission, and then hopefully an Artemis mission after that, who knows? So the exciting thing right now is that we have all of these different vehicles bringing astronauts to space, whether it's the International Space Station or beyond that to the moon. So stay tuned. We'll see what happens.
We are tuned. Thank you so much for everything and hope to see you soon.
Okay, thank you very much, Eitan. Ta-da.